This is the fifth experiment in OS. The fifth experiment in OS to classify the problems of syndromics using the semaphorons. Syndromes, and here I'm going to run the code in spider. Right. This is the first one. Yeah, this one is the first one to globalize the multiplex of empty, and then it will be weighted and found. Find is equals to empty. Find is equals to empty. Then global equals to also empty. Then the global empty multiplexes, and then elf is find is not equals to mutex. Then global minus mutex minus is equals to 1. Then if find is not equals to full, then global full minus is equals to 1. Then before signal find, if find is not equals to empty, then empty plus is equals to 1. If the find is not equals to full, then global the full plus is equals to 1. N is equals to hint input enter the size of an buffer, and buffer is equals to null. Text equals to 1, empty is equals to n, then full is equals to 0, while 1 is equals to print the producing consume choice into input enter your choice. Here you're going to enter the choice what you're going to get, and if choice is not equals to 1, if mutex is not equals to 1, then an empty is equals to 0. Print we're going to print the enter the values, and after that wait empty, then mutex and buffer appends input. Here we have to input the buffer reader to read the signal mutex full, and then uh, else print the buffer sorry buffer buffer is full. Choice is not equals to 2. If full is equals to and multiplex is not equals to 1, then wait full, wait mutex, print consumer value, then signal multiplex, then signal empty, else print the buffer is empty, else choice is not equals to 3, then else print invalid input. Okay, now I'm going to run the program. If I run the program, yeah, can you see this? Here enter the choice as 2 and choice as 1 and 4. It will be the product will be or the product you're going, then they enter the choice what you're going to enter the choice, and the choice what the product you are assuming. Here the product consuming exit, enter your choice, then the buffer is to be filled, and then enter your choice 2, then consumes value is equals to 2, then the product and the consumer enter your choice. Again you are going to enter the choice what the choice you are going to give. Now I'm going to give my choice as 2, and the consumption value is 4. Again I'm going to enter the choice as 2. Wait, if I give the choice as 2, then buffer it will tell as empty, and the product consume exit that will show as enter the choice as 3. And this is the first program. and this is second one. It is from random input, shuffling, choice, global mutex, and empty full, rendex, windex, count, bring, and define wait, find. If the find is not equals to empty, then global is equals to empty. Then mutex minus is equals to empty, else find is not equals to full, global is equals to full, then full minus is equals to 1, then else find is not equals to right, then the global right minus is equals to 1, then again define the signature. What is the find signature we are going to give? You have to enter the find signature and global empty, again empty plus is equals to 1, find is not equals to mutex, then afterwards plus is equals to else find is not equals to full, then global full is plus 1 is equals to 1, then read the given table. Given table, read the count is equals to 0, wait the mutex and read the count plus is equals to 1, otherwise read the count is not equals to 1. If the counter is not equals to 1, then read plus 1 is equals to 1, then wait right, then signal is equals to mutex. Afterwards the global count, render, print reader plus string ringer, read control plus as string counter. Afterwards ring plus 1 is equals to 1. If read counter is not equals to 0, then signal right, then signal will be the multiplexer, and the define writer wait write what's going to write the value as a global counter index, then again count is not is equals to 2. Again I'm going to take as count is equals to 2, then print the writer, then string window index. After that modify cmt plus control counter signal right, multiplex is equals to right counter, and index window is equals to 1, then read the I in the range of 15. Here we are going to range the I as a choice, and for this here the reader value read cnt as 1, modifier cnt to 2 and 4, 8, 16, 32, 64, 128, 256, and afterwards 512. This is the second one. And this is third one, and this is the last one, this one, and this is the from random input choice global minus 1, and else the choice copying numbers, copy 1, copy 2, and here you have to print the what the random value is granted, and the choice of waiting string to wait the signature and proto, and then number remove and plus is equals to 1. If length is equals to process number is not equals to 0, then break the statement. P is not equals to 2, C is equals to 0, J is equals to 0, while J is less than 5, then wait the rand protocol plus percentage of 5, then afterwards signal rand ponk, after that plus 1 percentage of 5, copy 1, remove brand X protos, J plus equals to 1. If the length copy equals to 1, copy of 1 is not equals to 0, else P is not equals to 0, then break that statement. Okay, for this here all are 1 alpha to the end number I have going as 1, P3, P4, P2, P2, P3, P1, P1, P2, P0 or the existing to the weights, and 2 afterwards I have given as the P2, P4